Hello, my dear students and the rest of the learners. Welcome to part 12 in C++ computer programming series, in which we are going to learn about classes. My name is MemJM, so you can simply call me Emily Swap. Object-oriented programming, which we abbreviate as OOP language, are the languages that are used to develop programs in terms of objects that interact to make up a whole, with each object having data and functions that are linked together to form a complex program. A program is therefore organized into objects that have relationships with each object, containing both the data and the processing operations that are necessary to perform the task. Each object has specific data values that are unique to it, which we call state, and a set of things it can accomplish called functions or behavior. A class is therefore a template that specifies the data and behavior of an object and is a static description of a set of objects. The classes are therefore treated as hierarchies, and inheritance lets you pass the data and behavior of an object in one class down the hierarchy. A class can therefore be seen to be a logical method that is used to organize data and functions in the same structure. They are declared using the keyword class, whose functionality is similar to the one for struct that we learned previously, but with the possibility of including functions as members in addition to the data members. The objects are therefore variables of type class. Once a class has been defined, we can create any number of objects belonging to that class. Each object is associated with the data of type class with which they are created. Therefore, a class contains both the data and the functions that are used to manipulate that data. This data, which is the class attributes, is normally referred to as data members, or the functions in a class that are wrapped together with the data members and are the only ones with indirect access to the data members are called the methods or member functions. In other words, my dear students and the rest of the learners, the difference between the struct that we learned in the previous presentation and the class is that in class, we include both the data members and the functions that manipulate that data, which is different from the struct or structure that we learned earlier. The concept of wrapping the data members and their methods together into a single unit is normally referred to as encapsulation. This data is not accessible from outside their class, and the only functions that can access that data is those which are wrapped together with the data in the class. Such functions that manipulate the data within the class are referred to as methods, just as I have said. This insulation of data from direct access by the program is called data hiding or information hiding. The data members and the member functions for a class form that class's properties. A class is therefore a user-defined data type that resembles a structure but with an additional member who is the methods, or what we call the member functions. The data members can have any type, whether defined by the language or by the programmer, that is you. An example of data members in a class can be R, X, Y, and Z. The member functions can manipulate the data, create and destroy class variables, and even define C++'s operators to act as the class objects. Some examples of member functions are sphere. Now, we also have this other function that I'm calling sphere, but in other ones, as we are going to see in this presentation, is that this kind of a function is called a constructor function, or this one is called a destructor function. And you can see that the constructor and the destructor are having the same name, but the second one, which is a destructor, is preceded by what we call the tilde sign. That's another function called volume. And you can also have a function called surface area. In other ones, my dear students and the rest of the learners, these functions, the way we write them is the same as the functions that we've been handling before in the previous presentations in this series. The only difference is that now we are introducing the concept of a class, and we are simply saying that the class has two types of members. It has what we call the data members, and it has what we call the member functions. The way we write our member functions is the same way that we write the functions, or that we have been writing functions in C++ series. Therefore, classes have several types of members, but they all fall into two main categories, which are the data members and the member functions or methods. It is the member functions that distinguish between a structure and a class. And just as I have said, the structure or struct that we learned previously did not have functions defined within the struct as a member. And that's what distinguishes between a structure and a class. A definition of a structure does not have functions as members, but a class has both the data members and the member functions. A class can therefore be said to be an object that manipulates itself. Why? Because it contains the data together with the functions that are used to manipulate that data. A class can have a special member function that we call a constructor function. Its name is always the same as the name of its class. Its primary use is declaring a new instance of the class. Therefore, the constructor function is the only member function that is called by the program. Therefore, a class constructor constructs the class objects by allocating and initializing storage for the objects and by performing any other tasks that are programmed into the function. It literally creates a live object from a pile of unused bits. An example of such a function is the one that I've already mentioned, which in this case is sphere. Its name is similar to the name of the class, which is sphere. In other words, we are saying that for you to be able to identify a constructor within your program, the name of the function, which we refer to as the constructor, is always similar to the name of the class in which this function is defined. So if the class is called sphere, then the constructor function will also be called sphere. A constructor can also be seen to be a special function which can be declared by naming a member function with the same name as the name of the class. This constructor function will be called automatically when a new instance of the class is created. That is, when declaring a new object of that class, and only then. Among the various constructors that a class can have is one without any parameters, therefore being called the default constructor. If the constructor is not explicitly declared in the class definition, the system will automatically create it for the class. In other words, it's not a must that when you are creating a program implementing classes that you include a constructor function. But what happens is that Once you have declared or defined the class within your program, the compiler will automatically create a constructor function on your behalf. The other special function in a class is called the destructor function. The destructor function has the same name as the class just as I have said, but with a tilde operator as its prefix. An example of such a function is the one that I've already shown you, which is the sphere. And as you can see, the name for this function is sphere is preceded by a tilde sign. The destructor function never takes the arguments and never returns values. Most destructors do very little. The destructor must have the same name like the class with a tilde as a prefix, and it must not return any value. In other words, it must return no value. If a destructor has no real purpose, you do not have to specify it. When the class variable goes out of scope, the memory allocated to that class variable is returned to the system. That is, an automatic destruction occurs. Remember, the work of a destructor function is simply to destroy the memory that had been allocated to class once its use is over. Therefore, programmers use destructor functions to free the memory occupied by class data in advanced C++ applications. The destructor is called automatically when an object is released from the memory, either because its scope of existence has finished or because it is an object dynamically assigned and is released with the operator delete. The destructor must have the same name as the class with a tilde sign as prefix, and it must return no value, just as I've said. The use of destructors is especially adequate when an object assigns dynamic memory during its life and at the moment of being destroyed when we want to release the memory that we used. C++ allocates memory for a class variable when you define the class variable just as it does for other variables. Instead of calling a class function through the main program, you can have them defined within the class as inline functions. Inline means that the compiler embeds the functions in the code rather than calling them as functions. By making a function to be inline, that function becomes a macro and is expanded in the code. This is done by adding the keyword inline to the function. For example, if you have a function called volume or a function called surface area whose data type is float, you can precede it with the word inline, and therefore you can define it, or you can declare it as inline float volume or inline float surface area. The advantage of using inline functions is that they execute faster because there is no function call overload involved, because no function is actually called. The disadvantage, however, is that if your functions are used frequently, your programs become larger and larger as functions are expanded. In object-oriented programming, the main function and its calls become smaller because the member functions contain the code that manipulate all the class data. And remember that these member functions are found within the class definition. The syntax for declaring a class is therefore as follows. We have the reserved word for the keyword class, followed by the name of your class. And then we have the opening braces, which defines the body of the class. And then we have what we call the permission label, which usually identifies the scope for the members. Then we have the list of members. Like in this case, we have one member called member one. Then you can also have another permission level. And then we have member under that permission level. And you continue listing the members or identifying the scope under which they can be utilized within the class. And then we have the closing brace followed by an object name and a semicolon. Remember that the syntax for defining the class, as you can see, is almost similar to the one for the struct that we learned in our previous presentation. However, the difference is that now we're including the members, and these members can be functions or data. And we also include the scope for each of the members, whereby class name is the name of the class, which is user-defined type and the optional field. The object name is one or several valid object identifiers. The body of the declaration can contain members that can either be data or function declarations, and optionally, permission labels that can be any of these three keywords: public, private, or protected. These make reference to the permission which the following members acquire. The private members, or the members listed under private, are the members of a class who are accessible only from other members of its same class or from its field classes or its friends' classes. These are identified using the keyword private. The private members cannot be accessed by anything but a member function. This is the true power of data hiding. My dear students and the rest of the learners, at this note or at this point, it is important for me to inform you that the difference between the normal structured programming using C++ and object-oriented programming using C++ is that object-oriented programming pays attention to the programs that are written using the class data type. And all the programs revolve around the classes. And that is what distinguishes between the ordinary structured programming using C++ and the object-oriented programming specialty of C++. And in that case then, when you code a program implementing object-oriented, or when you code your programs under the object-oriented paradigm, what we usually do is that we have various attributes or features of object-oriented programming. And one of them is data hiding. We have already looked at encapsulation. We have others like polymorphism and the rest. For you to be able to learn more about the object-oriented programming using C++, I would like to advise you that you visit Emily Swap ICT YouTube channel and follow the 95-part series of object-oriented programming in C++. The disadvantage with data hiding is that you must define specific data retrieval, data display, and data changing member functions that the main function must call to manipulate member data. We have the second level, the second permission level, which we call protected. Who are protected members, or who do you list under the protected category of members? The protected members in a class are those members that are accessible in addition to or from members of its same class and friend classes, and also from members of its derived classes. These are identified using the keyword protected. The third level is public scope or public permission level. What are public members? The members listed under public in a class are those members who are accessible from anywhere the class is visible. They are identified using the keyword public. The data members and the member functions declared explicitly as public can be used by other programs. If we declare members of a class before including any permission label, the members that follow will be considered by default as private because that is the default permission that the members of a class declared with the keyword class acquire. For example, if we have the class called the sphere and it has the members, the float members who are R, X, Y, and Z, and then under the public members, we have the function or the method called volume, which is of type float. And we have surface area, which is of type float. And then we have one object that we call calculate. In this case, you can see that the first four members who are R, X, Y, and Z have not been preceded by any permission label. So by default, those members R, X, Y, and Z are treated as private. It declares, therefore, a class called sphere, which is user-defined type, and an object called calculate of this type of class. For you to be able to perform any operation using the members of a class, you must have defined or declared an object or an instance of the class, just as it was for the structure or struct. And in this case, for us to be able to manipulate the members of our class called the sphere, then we have to define an object by the name calculate, which is of type class. Now, this class, therefore, contains 6 members. That is, this class. This class, as you can see, contains 6 members. Who are these members? We have the data members who are R, X, Y, and Z, while we have 2 members who are methods. And in this case, we have volume and surface area. Now, the members R, X, Y, and Z will be manipulated by the functions which are volume and surface area, because these are the 2 that can be able to access the memory locations for R, X, Y, and Z. But for that to happen, we must pass through the object for this class, which is called calculate. Now, in the body of the main program, we can refer to any one of the public members of the object as if they are normal functions or variables, just by putting the name, the object's name, followed by a point, and then the class member. When I say a point, is the dot operator. For example, if you wanted to access the member or the method called volume under class, just as I've said, you have to pass through the object for that class. And what is the name of the object for that class? It is calculate. So how do you invoke the function, the member called volume? You have to pass through the object called calculate. So you code it as calculate dot volume and a semicolon. This is a call statement. If you wanted to invoke a member of the class called surface area, and the value that is going to be returned by that function is assigned to a local variable called the area, then we have to write it as you can see. That is, calculate the surface area being assigned to the variable called area. If we want them to pass two arguments to the function called setValue under the class, then we could code it as calculate.setValue, and then we are passing two parameters to the function called setValue under the class. And these two arguments are received by the member of the class called setValue, but we must pass through the object calculate. We can also invoke or access a specific member of the class by passing through the object. For example, we can be able to access the data member called R, by having a statement like calculate.R. We can do the same for the member called Z with a statement like calculate.Z. So my dear students and the rest of the learners, as you can see, with the knowledge about the functions that we have learned in the previous series in this set of tutorials, and by learning about how we pass functions, then even handling classes becomes very easy. However, we cannot be able to refer to members of a class who are private to the specific class from outside that class, since they are private members of the class and they can only be referred to from other members of the same class. In addition, you can pass arguments to a class's function through the class's objects using call statements such as sphere calculate, and then we are passing to it 4 arguments who are A, B, C, and D. So, my dear students and the rest of the learners, this statement creates an object, an instance of class called calculate. And the name of the class is sphere. So calculate is an object of the sphere. And we are therefore passing 4 parameters or 4 arguments to the class's function, to the function, the class's function. A, B, C, D are the arguments. And the function, in this case, our function in this case is calculate. Now, the following program illustrates the functionality of a class. It determines the use of a class member functions. So this is an example of how we make use of classes. And my dear students and the rest of the learners, for you to be able to understand this presentation easily concerning classes, I would kindly like to advise you to go to Emily Swap ICT YouTube channel and check the part in which I have discussed and demonstrated deeply on structures. That is the topic on structures. Now, in this program, of course, the name of the program, I'm calling it class functions. And then this program demonstrates the use of class data members and the member functions. As usual, we have the outstream, the process directive. We are using a namespace standard. And then I'm declaring a global constant by the name pi and initializing it to 3.142. You can call it a constant. Then here is my class. The name of my class is sphere. So as I have said, you define a class by preceding it with the reserved word class or word class, then the name of the class. The name of my class is sphere. Then I have members who are public. Who are these members? One of them is R. which I'm going to be using to fact the radius of the sphere. I also have other members who are x, y, and z. In this case, I'm calling them the coordinates of my sphere. We have member functions or methods, and one of them is sphere. As you can see, my dear students and the rest of the learners, is that the name of this function is similar to the name of the class. So what name do we give to this function? This function is the constructor function. Now this function seems to be is supposed to receive 4 parameters. So that means the 4 parameters have to be passed to this function. And these parameters are all of type float. And of course, the names are as you can see. Then we have the body of that function. So we have the value received as x coord being assigned to a local, to the local member called x. Then we have y coord being assigned to y, z coord being assigned to z, and radius being assigned to r. As you can see, my dear students and the rest of the learners, note that the r, x, y, and z are already members of this class. And then we have this other function here, which we call destructor. The purpose of this function is to destroy the class or the memory allocated to class once processing is over. And I have the statement here to show you what this function does. It will display the message you are done with using the class sphere. And then this statement is for displaying the coordinates of the sphere, which has been destroyed. Then we have this other member who is called value. This member is receiving 3 parameters. Is receiving, in fact, not 3, is receiving 1 parameter. And also is accessing the constant memory location called a pi. So this function is returning volume. It's returning volume. And how is it able to compute the volume? Is by receiving the content of the memory location or the member called R and multiplying it by itself 3 times, multiplied by 4, then multiplied by pi divided by 3. That's the formula for computing the sphere. In this case, it is R cubed times 4 times pi divided by 3. And the results are being returned as a volume to the corner. We have the other function also for computing surface area, which is getting the content of the member called R and multiplying by itself, multiplied by 4, multiplied by pi. And that's how you get the surface area of a sphere. And that value, the results, are being returned as surface area and they're of type float. And that's the end of the class. Then we go to the main function, just as it is for normal C++ programs. We have 3 or 4 local variables of type float, who are A, B, C, and D. Now, the following statements will be displayed on the screen. The message enter the X, Y, and Z coordinates for the sphere, and then it gives room the user to key in the 3 values, A, B, and C. These values are arranged. One value is stored in C, the other one in B, and the other one in A, in that order. Then we have a statement that is requesting the user to enter the radius of the sphere, and the value is read. Then the values which have been read are sent to the member of the class called calculate, as you can see. So now, what does this statement do? This statement is doing a number of things. Before passing, we are having a class object being defined called calculate. Now, let's go to the class and see whether we have an object. When you look at the bottom here of this class, we don't have any object or instance for the class having been defined. So what happens is that before you are able to manipulate the class or members of the class, you have to define or declare an object for that class. So what this statement is doing is that it is declaring an object called calculate, which is of type sphere. And it is also passing the 4 parameters to it, or it is passing 4 parameters through the object called calculate to the class called sphere. Then we have the description for the sphere, the values that have already been entered. And how are they going to be displayed? Now, this statement here is able to access the value in the member called X through calculate object. The same for Y, the same for Z, and the same for R. And those values that are accessed are written on the screen. Remember that once this statement is executed, the compiler will not proceed to these other lines from here. What will happen is that once this statement is invoked, the compiler will go directly to the class here. So this is where the reading will be. This is where the compiler will come. The compiler will be able to perform all these activities here. It will be able to perform all these activities at this point. So in that case, every action that is being carried out by a function will be executed, will be done. And once that is done, then the compiler will come back now, the next statement here. Execute those statements in that order all the way. Now, what does this statement do? This statement reads the content or the value that is returned by the function called volume and displays it on the screen. The same happens. The value which is returned by the function called surface area will be displayed on the screen. That value will be displayed on the screen. And then the compiler will turn control back to the operating system and the program will end. Now, let's see how this program will behave. So we are going to copy this program just as it is. I'll copy this program just as it is, paste it in my C++ editor, save it, compile it, and execute it for you to see. My dear students and the rest of the learners, you can copy this program as it is. Write it down in your exercise books or in your editor, like one processor. Then paste it in your IDE environment for your C++ program. Execute it or compile it and execute it to see the results. So let's proceed. Let's proceed with our program. So let me open my C++ program. Here we are. Then I'm going to click on File, New, Project. Win32 console. And remember, my dear students and the rest of the learners, you don't need to follow this process if you're using another version of C++. What is important is for you to be able to start the editor where you can be able to code your program and then pick from the section for coding the program. Now, what is the name of my program? The name of this program that I want to give is class functions. And therefore, I'm going to call my project class functions. And then for the rest of the process, remember, I am making use of Visual Studio C++ 2010. So I'll right click here, point on under the click new item. I want to code a C++ file. I will call it class functions. So click on add. So let me copy my program just as it is and paste it there. So this is my program, which I've already discussed. I have coded it in my editor, which is one processor. So I'll just copy my program and then I'll paste it in Microsoft or in C++ editor. There we go. Then I'm going to click on save. Click on build, and then I'll click on build solution. What I'm doing is that I'm compiling my program. I'm compiling. You can see the compilation has taken place and it is successful, meaning that my program has no errors. If there are any errors, what we just need to do is to go through the program step by step as you undertake the debugging process. Now that my program compilation is successful, I can execute it by clicking on debug, and then I'll click on start without debugging. If you're using other versions of C++, you can just compile and run based on the menu that your program has. So we are getting the message, enter the X, Y, and Z coordinates of the sphere. Which statement is that? Let's see. Where are we? This is where we are. So this is the part that is being executed for now. Enter those coordinates, A, B, and C. So I'll type 2, 4, and 1. Once I press enter, what I expect is that I'm going to be requested for the radius. So let's press enter and see. There we go. So we are being prompted for the radius of the sphere. So if I type 3 and press enter, what will happen? We expect that the compiler will invoke this statement. An object for our class called sphere will be created. It will be called calculate. Then the values you have entered will be passed over to the class called sphere. Once it is passed the class called sphere, the compiler will move this section of the class. It will perform these activities here, perform all those operations each of the, as per the request by each of the functions under the class, and display everything just as you can see. It will perform those operations just as if those were normal members of functions. So let me press enter. You can see already the class has been executed, the functions have been executed, and we have the results with us. So the statement that will be next is this one. The description for your sphere is, you can see the values that we have entered are there. We have X, Y, and Z together with radius. Then the volume of the sphere is, this is a statement. And which function has been used to do this? It is the function under the class called sphere through the object called calculate. And that's the volume. And then we have the surface area. Now, the surface area is this statement here. You can see the surface area of the sphere is. Then we are picking the result that has been generated by the member of the class called sphere. The member is surface area. So that value is what is going to be displayed on the screen. And then from there, as you can see, there's this statement below here. You are through with using the class sphere. So sphere 2413 has been destroyed. So that is the work of the destructor. The destructor function. And where is the destructor function? This is our destructor function. So this function has been executed. And after executing, it is the one which is displaying this message, meaning that because our class is done, then the memory that has been assigned to it, the class called sphere, has been destroyed. It has been set free for other use. So let me press enter, and we are done. That's how our program is going to work. So you have seen how the class function has been able to perform the operation expected. Sometimes, however, you can also decide to declare a member of a class outside it using the scope resolution operator. However, if you have to define a member outside its class, you must prototype that member within the class. This information, my dear students and the rest of the learners, is not new. We saw how to do prototype under functions. If you forgot about how functions are used and how we do the prototyping, I would kindly advise that you listen to the presentation by the title Functions. That is, Programming in C++ or C++ Computer Programming, the part that we discussed about the functions, because that still applies in the case of our class. So you can still prototype your functions, that is the methods, and then you define them outside the class, as you're going to see. So if you have to define a member outside its class, you must prototype that member within the class. The scope resolution operator allows us to specify to which class belongs the member that we are going to declare. Therefore, granting exactly the same scope properties as it was directly defined within the class. For example, in a function called setValue, in the following code, we have resorted to the variables x and y that are members of the class CRectangle and are the only ones that are visible inside it and its members, since they are private. The only difference between defining a class member function completely within its class and to include only the prototype is that in the first case, the function will be automatically considered inline within the compiler, or in the second case, it will be a normal, that is not inline, class member function. One of the greater advantages of classes is that we can declare several different objects from it. The following is therefore an example of our program implementing the scope resolution operator. The results of rect.area and rectb.area gives different results. So let's see. Now, why? Why is rect.area and rect.b or rectb.area going to give different results? It is because each object of a class, like this case code, CRectangle, has its own variables, x and y, and its own functions, setValue, and area. In this case, the class C rectangle has two instances or objects, which are direct and direct B, each one with its own member variables and member functions. In other words, you may have several objects or instances of the same class. And because of that, each of them can be used to perform different activities or different functions. Like in this case, we are going to have two or several instances of the same class. The name of my file is class scope operator. It implements class and scope operator. As usual, we have the preprocessor directive. We are using namespace there. Now, the name of my class is C rectangle, and it has private members X and Y of type float. We have public members who are set values function. Now, this one is going to receive two parameters, both of type float. It's not returning any value. We have this other member called area. This is a function. It's not receiving anything, but it's supposed to return a value of type float. Now, the function called area is going to perform, is going to receive, is going to multiply, find the product of the content of X and the content of Y, and return it back to the caller as area. Then we have our destructor. We have our destructor member called C rectangle. So that's a class. Now, where are the members? Where is the definition? Where is the definition for our members? Now, we have this first definition here. And that definition is for the function concept values. Its scope is the class. And the name of the class is C rectangle. So set values is a member of the class called C rectangle. Of course, it is receiving two parameters. One is A, the other one is B, and they are both of type float. What is it supposed to do? Pick the value brought as parameter A and assign that value to X. Do the same. Pick the value received as parameter B and assign it in memory location or in the storage location or placeholder called Y. That's what it's supposed to do. That's the work of that function. And then we have this other member of the class who is a destructor called C rectangle. The purpose of this function is purely to clear the memory location that has been assigned to the class. Then we have the main function where we declare two objects of type class. So we have two members, two objects. You can even call them variables if you want, but these are objects to manipulate the contents of the class. One of them is called rect, the other one is rect B, and both of them are of type class. Remember, are of type C rectangle, because C rectangle is a class. Then we have local members, length 1, length 2, width 1, width 2 of type float. We prompt the user to enter the length and width of the rectangle. Is the length and width for the first rectangle, not length and rectangle, but it is length and width. Where we enter, first value is stored in memory location called length, the second one in memory location called width, 1. Then we prompt the user for the second length. Let me do a correction here. And we will do a correction here. This one is not supposed to be length and rectangle, but it's supposed to be length and width. Length and width. The same here is length and width for the second rectangle. Length and width. And the value which is red is going to be stored in the memory location called length 2 and width 2. Then from there, we pass the arguments to the class. So we are passing the first two values to the member of the function, to the member of the class, the member of our class called C rectangle, through the object rect. And we are passing to the same class, length 2 and width 2, through the same function. Now, if you look at these two statements, you can see that both of them are making use of the same member of the class called set values. But these two are different because each of them is making use of a different object. Then we are declaring another instance of class called rect A, and we are not passing anything to it. There's an object called rect A, and so type C rectangle. This is just an example to show you that you can declare an instance of a class without the need to pass parameters to it. Then we have the output statements there. The area for the first rectangle is, we have the value or the results for the function called area being displayed on the screen. And then we have the one for area under object 2, which is rect B, being displayed. Simply, what's going to happen is that once this statement is executed, the compiler will go all the way to the class, then perform the relevant activities. And then, once that is done, it's going to come back and proceed with where it had left, execute the next statement, go and perform the required tasks, and then bring the control back, then execute this statement and proceed. Pick the results from the member function called area and display it here. Do the same for the member called area, but at object 2. And then from there, return control back the operating system and end the program. So as you can see, we can be able to define a class and then just include the prototype. Like in this case, this is a prototype for the function. But then we do the complete definition outside of the class. Like you can see for the set values member, we are doing it outside the class. So let's copy this program. Let's copy this program just as it is, and then we paste it in our editor for C++, and then see how this program will behave. The name of our program or the name of our file is class scope operator. So I'm going to go to my C++ program. Let me close this file, close that file, close solution, then start a new project. I'll start a new project using the same procedure. The name of my program we have seen is class scope operator. So I'll call it class scope operator. Class scope. Remember, you are free to give your own ones or your own names. Class scope operator. I'll also call my file. I'll give my file the same name. Remember, it is class scope operator. And you are free to give your own ones or your own names, my dear students and rest of the learners. Let me now copy my program. This is my program. I'll copy my program from my editor. There we go. I'll copy it and I'll paste it in my editor. So this is my program. Then I'll save it, compile it, and wait for compilation process to complete. As you can see at the bottom of this screen, my compilation is successful. So I'm going to run my program. There we go. You can see that now we are being prompted. We are being prompted to enter the length and width of the rectangle. Now let me rectify this statement straight away. Enter the length and the width. Remember, you can always make changes as necessary. Length and width. I don't need to continue having the errors in my program. So what you do is you can always make correction. You can always make correction to your code, save it, and then compile it afresh. So I'll build my program again. It's successful. And then from there, I can run my program. You can see we have been able to rectify the error. Enter the length and the width for the first rectangle. So enter 1 and 2 or 3. Enter the length and the width for the second one. We'll enter 4 and 7. You can see it is able to compute the area. So we are getting area for the first rectangle is 3, and area for the second rectangle is 28. Which parts are those? So my program or our program has been able to compute or execute the functions. It has been able to execute this function here twice. That is 1 and let B, this statement here, and the other one, this statement here. And the results are different, as you can see. And those are the results that are being displayed on my screen. So I'll then press any key to continue. And that's how you can be able to define your functions outside of the class. Let's see at something else that you can be able to do. We can also make use of pointers. Remember, my dear students, that as the learners we said before in the presentation under pointers, that with the use of pointers, you can be able to perform all other operations that you can perform in C++ programming. All the operations can be performed using pointers, from declaration all the way to files. So what are pointers classes and how do you go about it? It is perfectly valid to create pointers pointing to classes, and the class is considered like any other data type. For example, you can have a pointer to an object of C rectangle class, and this pointer is, I'm calling it rectb. So this is a pointer to the class called C rectangle, but now this pointer is pointing to the object called rectb. Just as it happens to other data structures, to refer directly to a member of an object pointed to by a pointer, you should use the operator for the pointers. You can use either the pointer, or you can call it the arrow, or the dot operator. For example, the following are some statements for manipulating values in members of a class using pointers and the class operators and what they mean. So if you have a statement like that, the reference operator X, it simply means that this statement is pointing to the memory location called X, so pointed by X. This other one is address of memory location called X, or call it address of the object called X. X dot Y simply indicates that that is referring to member Y of object X. Well, this other one simply means that member Y is of object pointed by X. This other one, x, ry, simply means that member y is of object pointed by x. In other words, my dear students and the rest of the learners, the knowledge of pointers fully apply in this case. If you forgot about pointers, kindly go through the C++ computer programming series under the topic pointers that we learned before. If you want to refer the first object pointed by x, you code it like that, subscript a 0. Then for the second object pointed by x, use subscript 1. And then you continue that way to the end object. Therefore, the following program illustrates how to apply pointers to classes. It is used to compute areas of various rectangles whose dimensions have been entered by the user. Here we go. So we have the name of a program or the file is class pointers. Its pointer to class is example. Then we have our class here is C rectangle. We have two members who are private, width and height. Then the public members are set values, which is receiving two parameters or two values of type integer. We have this other member called area. Then we have the function or the member called area, who is a function, is supposed to multiply the value of length and width and return that as area. Then we have the destructor function. That's the end of the class definition there. And then we have the prototype. Remember, this is the prototype for the function called set values, and then its definition is outside the class definition using the scope resolution operator, just as we saw. And that's exactly what that function does. The rest, this is a destructor of the location used by the class. Then the rest of the program is, as you can see, the first statement is where we are declaring, as you can see, we are declaring pointers to three objects or to two objects of type class. The first object is A. That one has no pointer. But the second one is a pointer called B and a pointer to the object called C. Then we have new C rectangle, and we are referring to the that element in that class. Then we have this other statement, new C rectangle, and whatever that is returned is assigned to B. Then we have the memory or the address of the object called A being assigned to the object C. We have local variables, height and width. And then we are also declaring and initializing the objects as follows. The address for width is assigned the pointer called width pointer, while the one for the memory location called height, the address of memory location called height, is being assigned to the pointer called height pointer, and they are of type integer. Then we are prompting the user to enter the height and width of the first rectangle, which is length and assigned to those memory locations using the pointers, as you can see, the pointer to width and the pointer to height. And then we have the content of the memory locations pointed to by width pointer and the one pointed to by height pointer being passed to the member of the class who is being manipulated by the object called A. And and the member of the class is set values. So once this statement is executed, the control will be taken all the way to the class through the object A. So the compiler will come here, perform all those tasks, and once done, go back and continue with the next statement. So that will be the next statement. The result of the computation from the member on area will be displayed. Then the program is prompting for width and the height for the second rectangle. They are read through pointers. And then they are passed the two values being pointed to by height pointer and width pointer. Those values are passed over to the class through object B to the function member called set values. It is executed, and then the value returned is displayed here through the pointer. And then we are prompting for the next height and the width. They are read through pointers. Then the values of memory location called height and the one for width, who are being pointed to by the pointer called height pointer and width pointer. Those values are read, then they are passed to the member of the class called set values through object C. And the value after computation is returned, and that value returned by the area function is displayed on the screen. Then we are prompting for the next width and height. They are read to the pointer, they are passed to. The values are passed to the function called set values, and the result is going to be stored as the second element and object D. And then we have the area being displayed, the area for the content whose address is 0, and the one whose address is 1. Remember, this statement here, there's nothing we have assigned to that area of that object. So we expect the value which is there by default to be displayed. But for D1, we have already done it to this statement here. So we expect a certain value there. And then once that is done, the control is taken back to the operating system and the program ends. Let us code this program in our C++ program and see what will happen. So I'm going to open my program as usual, C++ program. I'll close the solution. Then I'll start a new project. Now, the name of my project is class pointer. And then I'll proceed and create a file. I'll create a file, a source file, which is a code in C++, and I'll call it class pointers. So I'll copy my program as usual. This is my program. I'll copy my program from my word processor editor. I'll copy this program, and then I'm going to paste it on my editor. So that's our program. I'll save the program. Then I can compile my program. As you can see, my compilation is successful, meaning that my program does not have any syntax errors. I can then execute this program. Let's see how it behaves. There we go. We are being prompted for the height and the width of first rectangle. So I will enter 3 and 4, or 34 and 2. You can see it has computed the area through object A. Let me enter the second values, 24. You can see the computation has been done and the value being pointed to by the pointer for object B has been displayed, which is 8. Let me enter the second. You can see it has computed the value for that area, and it has been displayed through the pointer to object C. Let me enter the next value. You can see we are writing out the content of the object or the element, the content in the memory location being referred to by address 0 or index 0. There's nothing there. You can see the kind of value that has been displayed. But because you have assigned the results that you have gotten to the second object, the second member of the class, whose index is 1, you can see we have 18. Of course, 3 times 6 is 18. And that's the end of our program. It's as simple as that, my dear students and the rest of the learners. Remember to save. You can always save your program. Other than that, what else can we do? So we have been able to code this program. We have made use of pointers, and you have seen what we have done. Now, other than that, just like other programs implementing functions in C++, you can prototype class member functions and define them after the main program, and pass parameters to it while abiding the same rules of passing parameters. However, you must indicate the scope for each method in terms of the class they belong to. The following is therefore a program illustrating how to implement a class data type using pointers and function prototyping. And this program is a program we have handled in the previous presentations in this series. It prompts the user for student name and student scores, then computes the total score and displays the student's information on the screen. So this is our program. Look at the class. Our class is called student scores. It has the following members. These are the private members. Then we have now included the functions, the member functions, who are get data function, and this is the prototype now. Then we have the prototype for computing sum function. We have a prototype for display data function. And you can see these ones are making use of pointers to the parameters. Then we have also a destructor function for the student scores, as you can see. And we are defining one object for this class called the student. Now, as you can see, void get data, void compute sum, and void display data, as well as student scores, those are prototypes. They are prototypes. But I repeat, void get data, void compute sum, and void display data, those are the prototypes. For the destructor, that function is complete. Because you know the work of destructor is to set the memory that has been allocated to class free once the class is no longer in use. Now, these prototypes, these functions will be defined later after the main. So let's go to the main. This is our main. So we have pointer declaration. We are declaring a pointer called student scores pointer, which is of the type student scores, which is class. Then we initializing the pointer, the memory address for the class object. Then from there, we're invoking the members. So the first one is the get data. So we are invoking get data member function by passing to it the memory location being pointed to by the pointer called scores pointer, student scores pointer. So once this statement is invoked, the compiler will go and look for the prototype for that member. Here we are. And then it is going to know that it's receiving is receiving a parameter, which is a pointer to a class, to an object of a class. Then it will go where that function is, skip the rest, and go there. So we have our function called get data. Is receiving a parameter, which is of type student scores. And this get data is a member of the class called student scores. So it's going to perform the following activities. Prompt for the username, and the scores for each of the units. And those values will be stored in the member, will be stored as members of the class. As you can see, each of them has a dot operator, like the last statement here. The value entered as OOP score is going to be stored in the memory location being pointed to by the pointer called student scores pointer, which is a member of the class. Once that is done, the control will be taken back to the main program, main function, and invoke the next statement, this one, to invoke this statement. Remember, we have a member. Don't forget this member called the student. So the same will continue until the class is destroyed and the control is taken back to the operating system. So each of the functions, as you can see, after the main, we have that first function. We have the second one here for computing sum, as you can see. And it is going to perform those activities there. Then we have the third one for displaying the results. All these are members of the class, but they have been defined after the main. So you can see that with classes, you can do the prototyping under the definition of the class. Like for these functions here, you can prototype them. Once you prototype them, just like it is for functions, then you have to do complete definition at the end of main or after main, as you can see. And once you have done that, then your program will be good. So let's code this program. Let's copy this program just as it is, and we paste it in our editor. We compile it, we run it, and see the results that we are going to get. The name of our function, the name of our program is class function pointer. So I'll go to my C++, close this current program and the solution, then start a new project. I'll call my project, when do we have the name? It is class pointer function. Let's remind ourselves. My file, I'm going to call it what? The name of my file is class function pointer. So I'll call it class function pointer. So my project name is class function pointer, meaning it's implementing classes using pointers and the functions. Class function pointer or class pointer function. Then I'll have my source code, C++ source code, and the name of my source code file is class function pointer. Remember, this program is also demonstrating on prototyping. So I'll copy my program. I'll copy my program from my editor, just as it is. In your case, you can just copy your program from the screen and then just paste it in your editor. So let me copy my program. Then I'll open my C++ program. That is my C++ editor. That is integrated development and environment. I'll paste it there as I have done. Then save it, compile it. So there we go. Our compilation is successful. So I'll run my program. There we go. You can see that the part which is being executed for now is the one which is prompting for data. So this is the function. This is the member function that is being executed for now. So I'll key in the details. For example, mem, then score for each of them. Once I press that enter key, you can see we are being told that the scores for mem are. So which function is that? The member who is being executed now. Already, the computation for sum has been done. And we are now displaying the results, as you can see. So the last bit is the last function here, which is displaying the values, that is display data member of the class. You can see it has been able to pick my values as entered, and also it has displayed the total, whose total is. So as you can see, my dear students and the rest of the learners, you can always implement classes, the pointers, the functions in the normal way that we do it. But what is special with the classes is that the member functions are included within the class definition. You can define the function fully under the class, or you can prototype the member functions or the methods, and then you can define them fully after the main, but don't forget to include the scope resolution operator, because you can define functions for different classes. You can have more than one class in the same program. So it is your duty and responsibility to indicate or inform the compiler the scope of each of the function definitions by identifying the class to which the member belongs. And therefore, my dear students and the rest of the learners, with that, then we have come to the end. We have come to the end of part 12. We have come to the end of part 12 of this presentation under classes. You can now continue and listen to part 13 of this series, in which we are going to learn about the files. Congratulations, therefore, for learning part 12 in C++ computer programming series by the title Classes. You can access the rest of the parts in the series, as well as other computer or ICT videos, by clicking or tapping on MLSwap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emilyswap@gmail.com. Thank you very much for listening to me. Let's meet in part 13 of the series, and God bless.